Hi class, we're working on lesson number 5, and lesson number 5 is continuous random variables, and it's also called normal distributions. We just got done with the end of lesson number 4 where we showed the difference between a discrete random variable versus a continuous random variable. If you remember, a continuous random variable can have fractions or can have decimals, where a discrete cannot. The items needed for this lesson are going to be your TI-83 calculator, and you also need to click on the link in the web page for this course to get the normal distribution chart. I am going to show you what it should look like, something like this. And we're going to learn how this works. So areas of a standard normal distribution is on the upper left. You see curve right here, and then you see a bunch of numbers. Let me zoom out just a smidge here. Okay, and then you see a bunch of numbers. So the chart looks something like this. Okay, we're going to use this chart for this lesson. So please, if you don't have it, pause the video and then click on the link, download the chart, and then we're going to use it for the lesson. So here we go. I'm just going to zoom in again a little bit. All right, so here we go. We evaluated binomial probability distributions in the last lesson. These distributions use discrete random variables. That was lesson number 4. This lesson we will be discussing continuous random variables. Continuous random variables outcomes are approximately normally distributed. Approximately normally distributed is 3 words that also mean bell-shaped curve. I like to use bell-shaped curve. It's a little nicer wording. People usually are have that kind of reference in the real world. A lot of people talk about bell-shaped curves. Normal distributions can also be called bell-shaped curves. So each bell-shaped curve has a mean and a standard deviation. Okay, and I just said a second ago, please print the link titled Normal Distribution from this class's homepage to complete the rest of this lesson. And that was the chart I just showed you. You'll need this chart. So here we go. A typical bell-shaped curve looks like this. So we have a mean here. Okay, the mean is usually x with a bar on the top. Okay. Now what we do is we go 3 ticks to the right. So we're going to go tick, tick, tick to the right and tick, tick, tick to the left. Each one of those tick marks is a standard deviation. So this is a mean plus 1 standard deviation. This is a mean plus 2 standard deviations. And then this is a mean plus 3 standard deviations. When add to the right, subtract to the left. So this would be the mean minus 1 standard deviation. This tick mark is the mean minus 2. And then this would be the mean minus 3. Now, does there exist more than 3 tick marks to the right and 3 tick marks to the left? Absolutely. I mean, you can have a 4th and 5th and 6th and 7th to the right and etc. to the left. The thing is, if you notice where most of the curve is usually within 1, negative 1 to 1. From the mean. That's where most of the meat of the curve is. As you go to the right, notice how this area over here gets smaller and smaller and smaller, and same thing over here, the area to the left gets smaller and smaller and smaller. Those are called tail areas, by the way. This looks like a right tail over here. That's like a tail area. So that'd be a right tail, and this is going to be a left tail. We use the terms right tail and left tail in the coming lesson, so it's nice to get down that language now. Now, underneath each one of these bell-shaped curves is something known as a z-score. And a z-score is the number, the definition, the number of standard deviations you are from the mean. The number of standard deviations you are from the mean. So if you are at the mean, underneath these you're going to have a reference. Z is a reference. If you're at the mean, that means you are z-score of 0. Then every tick mark is a standard deviation, so that would be a z-score of 1 for that tick mark, and 2 for that tick mark, and 3 for that one. Negative 1 for that one, negative 2, and negative 3 for that one. So those are all reference numbers. Okay, now this curve could represent any continuous type of variable. Continuous variables, again, have fractions. So this could be continuous random variable would be women's heights, men's heights, women's weights, men's weights, how long a life expectancy of anything is, the time it takes for anything to happen, because time is always a decimal answer, so we can use any of those as references, and they end up being a bell-shaped curve as its shape. Now our goal in this lesson is we're going to color in some of these shapes. So eventually we're going to draw a bell-shaped curve, and we're going to color in that particular area of the curve, and I'm going to show you how to find the percentage of things in that area. And then another question will be, well, let's find the percentage of things in that region, and then what about the percentage of things over in that region? And we're just going to move ourselves around, and I'm going to show you how to get these areas. So it's not so bad. Okay, so here we go. Let's do some questions. First, before we tackle these questions, we'd like to cover some properties. There are 3 properties. We already covered the first one. There exists z-scores more than 3 and less than 3. That was the tick mark. So you can have z-scores of not just 1, 2, and 3, but 4 and 5 and 6 and 7 and 8 and 9 and 10, etc. And also the other side of -3, -4, -5, -6, -7, etc. The left side of the curve is equal to the right side of the curve. What we mean by that is if we break up a curve, a bell-shaped curve, at the mean, that's supposed to be in the middle, okay, at the mean, right in the middle, you'll notice that the right side and the left side can be folded onto one another, so they're mirror images of one another. That's going to come in handy in just a second. And the third one, it says 0.5 of the curve is on the mean going left and 0.5 is on the mean going right. Well, 100% of people's weights, people's heights are in here, so from the middle to the right is half of the chart, and from the middle to the left is the other half, because the middle breaks it up in halves. And we're going to use that. Okay, so here we go. We're going to jump right in. So the first question says, okay, find the percentage of people or things that lie under a bell-shaped curve. Another name for bell-shaped curve is normal distribution. Given between z equals 0 and z equals 1.67. So here's what we're going to do. We're going to draw ourselves a bell-shaped curve. Always label 0 no matter what. So z equals 0 is always the mean. That always goes in the middle. And because we have a positive z-score, I don't do tick marks of 1 and 2 and 3. I just simply say, oh, that's a positive z-score, so I put a tick mark to the right. I label it 1.67. I write my z's like that so you don't confuse them with the number 2. And we want between those two. So we're going to go like this, we're going to go like this, and we're going to shade in that region right here. Now, the other way you can write it is in probability or algebraic notation. Notice that z-score is sandwiched between 0 and 1.67. And your homework, I believe there's, let's say 20 or 30 questions on homework for this, and half are going to be in the English notation, and the other half are going to be in the algebra notation. So I kind of use both here for this lesson. Well, between 0 and a z-score is exactly what your bell-shaped curve chart talks about. So here we go. 1.67 is the number. So what we're going to do is, if you notice in the upper right-hand corner, they give you a bell-shaped curve, they give you 0, and they give you a z-score, and they color in between. So that's exactly what we're asking for in this particular question. So on the left-hand side, we're going to look up 1.6, okay, 1.6, and then we're going to scoot over for the second decimal, and you'll notice that we're going underneath the 7. There's 1.67. So this would be 1.6. If you notice up here, that's 0, so this would be 1.60, 1.61, 1.62, 1.63, 4, 5, 6, and that's 1.67. And we're getting back a point, 4525. So we're gonna go back to our question. And here is 0.4525. That's the probability. And again, people don't like to think in terms of probability. So we're going to move it over 2 decimals, and we're going to say 45.25%. So that's the percentage of things that lie between a z-score of 0 and a z-score of 1.67. Okay, so we're just doing generic z-scores now. The second half of this lesson, we're actually going to get into applications. But right now, we need to know how to figure out these bell-shaped curves. So here's another one. We would like to find the area between a z-score of 0 and a z-score of negative 2.34. So draw ourselves a bell-shaped curve. We label the mean to be 0. And negative now, so we're going to go left. And notice in the question here, I missed the negative sign right here, so I'm just going to put it in. Again, z is sandwiched between 0 and negative 2.34. Okay. So here we go. Negative 2.34, we went between, so we're going to put a line here. We're going to put a line here. And we want to go between those two. So we're going to just color in that region right there. And again, that's between 0 and a z-score. We're going to use property number 2 now, which tells us that the left side and the right side are mirror images. So instead of looking up negative 2.34, it's the same as looking up positive 2.34, but we're going to put the area on the left side of 0. So we're going to look up 2.34. So here we go. 2.3. Now if you remember, that is 2.3, and that is a 0, that's a 1, that's a 2, that's a 3, that's a 4. So that's negative. That's 2.34 right here. And if you see, that's 0.4904. So here we go. So the area in there is 0.4904. Now remember, that's area, and area cannot be negative. So just because the z-score is negative, don't make that negative, because you can't have a negative area. What that negative on the z-score means is this area is negative, which is left of the mean. But the area is 0.4904. And again, that's the probability, and then we turn it to a percentage by just writing 49.04%. So that's the percentage of things that lie between z equals 0 and z equals negative 2.34. Okay, so let's do a few more. We have a question here that says, what's the area between a z-score of negative 0.81 and 3.01? Okay. Always label 0, whether the question has it or not, because that separates the negatives and the positives. On the left, we have a negative 0.81. There we go. And on the right, we have a 3.01. I don't concern myself too much with being accurate in terms of spacing. I know that 3.01 should lie a little bit further away than negative 0.81, but as long as you get the answer right, I'm happy. So always break it up at 0. All right, so we want this entire area. But the way to do this now, we're going to have to do it in halves. So first we have to look up 3.01, and that's going to give us the area between 0 and 3.01. So I'm going to scoot over here to my chart. And I'm going to scoot down. I'm going to look up 3.01. So this is 3.0. If you go up to the top here, you're going to say 3.00. This is 3.01. So that is 0.4987. I'm going to scoot that off. That goes here. 4987 is the area between 0 and 3.01. And then we look up negative 0.81. So we go down 0.8 and then over to 1. And that's going to be 2910. That goes right here. And what you do is you take this area and you add the two together. So we're going to say 2910, add to 4987. And if we add the two together, we're going to get back, let's see here, that's a 7, that's a 9, that's an 8, that's a 7. So 0.7897, that's the probability. We move it over 2, and the equivalent answer in terms of a percent, 78.97% of things lie between negative 8.81 and 3.01 z-score. Remember, z-score stand for standard deviations. So within the mean, from negative 0.81 standard deviations to positive 3.01 standard deviations, there exists 78.97% of the population. Okay, so there's basically 7 areas. We just found a couple of them, and I want to show you how to find all 7. But here's some hints for you. Hint for finding answers under a bell-shaped curve. If the area you need under the bell-shaped curve crosses 0, add. If the area you need does not cross 0, subtract. Now, I don't tell you what to add and subtract, but you'll know, trust me, when doing the question. If the tail, which again is another word for the end of the regions, there's a left tail and a right tail. So tails would be, that's a left tail, and that's a right tail. So if there's a tail as part of the answer, part of the region that you want for a question, then you have to use 0.5 as part of the answer. Sometimes you have to add, sometimes you have to subtract 0.5. So again, if you cross 0, which is the mean, if you cross 0, add. If you don't cross 0, subtract. If the tail, 0.5 is included. So let's use these hints here. So that's a lot easier, I think, than memorizing 7 different ways of getting areas. So we want more than z-score of 1.16. Again, another way of saying that is z is greater than 1.16. More than and greater than mean the same thing. So here we go. Okay, we label z equals 0 and 1.16. More than is to the right. Okay, first thing, does my area cross 0? You're going to say no, so that tells you to subtract. Is the tail involved? Yes, so then you're going to say 0.5 is needed as part of the answer. Okay, so what we're going to do is we're going to look up 1.16. So we go over here, and here's 1.1. We're going to go to where we're underneath the 6, which is right there. So 1.16 is 0.3770. Again, that though goes there, between 0 and the number you looked up. It doesn't go in the tail because the bell-shaped curve chart only tells you the area between 0 and the z-score. So you always have to go between those two. So we looked up 1.16, we got that, that's the area. So from the middle all the way forever to the right is half the bell-shaped curve. Half on the right half on the left half. So if I know the 3770 plus the tail area is half of this chart, then you basically just take the 0.5 and you take away the 3770, and that gives you back the 0.1230. So we're going to look at 0.123, that's the probability. Turn that into a percentage. We're looking at 12.30% of things lie right of a z-score of 1.16. Okay. A few more. What if we want the area under a bell-shaped curve less than negative 2.85? I keep forgetting my negatives over here. Z-score less than negative 2.85. After a while, you don't have to draw these bell-shaped curves. It's completely up to you. I like to do it just for visual effect. Okay, so 0 is the mean. Negative 2.85 is negative, so it's on the left. We want less than. Less than is always left of. Again, we're going to ask ourselves two questions. One, is the area crossing over 0? No, so you're going to say I'm going to subtract. Is the tail involved? That's yes, so 0.5 is needed. Got it. Okay. So we want less than negative 2.85. Okay, so we're going to look up 2.85 because we look up positives just like negatives, 2.85. So we're going to go right here, 2.8, 0, 1, 2, 3, 4, 5. There we go. And we're looking at 0.4978. That goes here, 4978. It's always between 0 and the number that we just looked up. In this case now, from the mean over, half the chart is on the left. So this plus the tail is half. So if we take half and subtract, like we're saying here, 0.5 is needed. So 0.5, and if we subtract the 0.4978, 0022. That's the probability. Move it over 2 decimals, 0.22% of things lie in that area over there. And again, remember, everybody thinks in terms of percentages, a little bit easier than probabilities, but either answer is acceptable. I believe your textbook usually uses probabilities, but changing them to a percent is never a bad habit to get into. All right, here we go. More than negative 0.39. Negative is on the left. We want more than, so we want to go here. Not only do we want more than up to 0, but don't stop. We want more than. We want everything more than is to the right. Okay. So we know two things. Does my shaded region cross 0? You're going to say yes, so that means you're going to add. That's a check mark. And is the tail, yep, tail over here is involved, so 0.5 is needed. Okay, so we look up 0.39. Okay, 0.3. Go all the way over to 9, and you're looking at 0.1517. That goes here, between 0 and the number we just looked up. From here all the way over is the entire right-hand half. So if we take the right half and add the 1517, we get back 0.6517. That's the probability, 65.17% of things lie in the shaded region there. Okay, so I think we're doing pretty good. Let's try another one. Less than negative 6.78. Or z is less than negative 6.78. Less than and less than are both same type of question. One is using the English wording and the other one's using the mathematical algebraic notation. So middle is 0. Negative 6.78. See, that's beyond 3 ticks. So that's why I say you can have anything beyond 3. So we're over here. Negative 6.78. We want to go less than, so that's left. Got it? If we use our hints, check number 1. Does our shaded region cross 0? You're going to say no, so that means you're going to subtract. And check number 2, is the tail part? Yes, it is, so we're going to need 0.5 as part of our answer. We're going to have to use that one. All right, so here's the thing. I like giving this chart. This chart is also available in your textbook, but this one's a little better than the one in your textbook because it goes a little longer. Your textbook only goes to 3.0. This one actually goes to 3.6. And if you notice, where does 6.78 lie? It's not on the chart. So this one, which comes out of a different book, is also a little nicer. It says for values of z greater than or equal to 3.70, just use 0.4999 to approximate the shaded region under the standard normal curve. So we just use 0.4999. Okay. So between 0 and that number is 4999. That's almost the whole half already. Now remember, from the mean all the way over is half on the left. If I know this, plus this is half. So if I take half, I take away the 4999, I get back 0.0001. That's the probability. Move it over to 0.01% of things lie in that shaded region over there. So it's pretty rare that you're going to get something less than this z-score, because this z-score is so far away from the mean. There's hardly any area left over here, which means it's just very rare that you're ever going to get that. Okay, so we're doing pretty good. Here we go. One more. Between a z-score of 1.90 and 2.43. Okay. 1.90 is a positive, and 2.43 is also a positive, and we went between those two. So that's the shaded region we're looking at right there. And you notice also here algebraically z is sandwiched between 1.90 and 2.43. So that's where the between comes from. So does my shaded region cross 0? No. So you're going to subtract. Is the tail region part of the shaded region for the answer? No. 0.5 is not needed. So what am I going to do? I'm going to look up 1.90. So go over here. 1.90 is, oh, I screwed up a little bit, 4713. So let me just go right here. 1.90 again was 4713. And then from the mean to 2.43, okay, 2.40123 is 0.4925. So that's between 0 and 243. So we know all of this here, plus the shaded region, is the 4925. So if we take the 4925 and we take away the 4713, that'll just leave us with the shaded region. And that's going to give us back, let's see, a 2, a 1, a 2, and a 0. So 0.0212 is the probability. And 2.12% is the percentage of things that lie in that shaded region between a z of 1.90 and a z of 2.43. And again, 1.90 stands for the number of standard deviations from the mean. So between those two standard deviations, 2.12% of the population exists. Okay, so that's how you do z-scores. What lies next is applications of z-scores. And If you wanted to take a break right now, I understand. So if you want to pause the video, feel free. What I'm going to do is I'm going to do the second half of this lesson. There's usually 2 lessons in this particular week, so I'm just going to go on and do the second half. And here we go. So applications now. So now we learned how to do z-scores. Now we're actually going to apply them. So applications of bell-shaped curve. Again, it's called normal distribution. We're going to use the skills we just acquired in the first part with answering z-scores to answer applications. So we will still be using the bell-shaped curve. So here we go. So let's take IQ scores. They're approximately normally distributed, which those 3 words mean bell-shaped curve with a mean, need a bar there, of 100 and a standard deviation of 16. All right, so if we put the tick mark in the middle, the tick mark in the middle is the mean. So in this particular case, that's going to be 100. We always go 3 tick marks to the right and 3 tick marks to the left. To the right is adding a standard deviation, and if you notice the standard deviation is right there, 16. So we're going to add 16, and add 16, and add 16. Then going to the left, we're going to subtract 16. So subtract 16, subtract 16, subtract 16. So there's our values that represent 1 and 2 and 3 standard deviations, and -1, -2, -3 standard deviations. Underneath each one of these is now your reference number. This is the mean, so that's a z-score of 0. And this would be then a z-score of 1 and 2 and 3, and -1 and -2 and -3. And that's why I say we always go -3 to 3 because that's where the majority of stuff, the vast majority of stuff lies. Could we go higher than 148? Sure, there's been IQs that are greater than 148. Can we go past that? You can. You're going to get z-scores higher than 3, but if you notice, there's very few people off on the tails. So that's just basically what we do. We always go -3 to 3 and then we stop. Okay? But there does exist a 4, 5, a 6, a 7, and etc. Okay, so that's what the bell-shaped curve looks like. Now we can answer some questions based on that bell-shaped curve. So let me scoot this up just a smidge. All right. So I would like to find the percentage of people who have an IQ of more than 132. Well, what we have to do here is we can't answer a question with a number because 132 is not in our Z chart. So what we have to do is we always have to do one step here. We have to convert each of these questions to a z-score question. So when we're saying more than 132, if we look at our chart here, 132 is exactly a z-score of 2. So we can change this question to say, what percentage of people have an IQ more than a z-score of 2? And now we can answer it because we can just draw ourselves a bell-shaped curve. There's my z equals 0. There's my z equals 2. Okay. We want more than 2. And we're right back to the lesson we just did a second ago. So let me scoot that up a little bit. More than 2. So you're going to look up 2, or 2.00. There's 2. 2.00 is 0.4772. And that is the area that goes right here. And we know that the area in the tail, so the area did not cross over 0, so you're going to subtract. And from the middle all the way over to the right is half. So this plus this is half, so we're going to take half. We're going to subtract the 4772, 0.228. So we're going to say 2.28% of people have an IQ more than 132. All right, let's do another one. I'm going to fold this piece of paper a little bit over here. Okay. Next question. How about what's the percentage of people who have an IQ less than 116? I'm giving you nice numbers to start off with. We have to convert, because if you notice, there is no 116 on your normal distribution z-score chart. There's just z-score, so I have to convert to a z-score. So less than 116, if I look at my bell-shaped curve here, the mean was 100, every tick was 16, 116 happens to be a z-score of 1. So 116, we can grab the z-score right off the table. So this is going to be less than 116, equivalent to a z-score of 1. So we draw ourselves a bell-shaped curve. Z-score of 1 is to the right, and we want everything less than that. Got it? And our area crosses 0, so we're going to add. The tail over here is involved, so 0.5 is needed. And we're going to look up 1 or 1.00. So here we are. 1.00 is 0.3413. That goes between 0 and the z-score of 1 we just looked up. This whole left is half. So if we take half and we add the 3413, we're going to get back 8413, which turns into 84.13% of people have an IQ less than 116. So that's the percentage. What makes this awesome is we don't have to go out and actually ask people their IQ. So long as we know the mean and the standard deviation, we're pretty much ready to go. We can just figure it out just using this kind of stuff. All right, so let me fold this over. Okay, one more question. Here we go. Between an IQ of 84 and 148, what percentage of people lie in that region there? So we need to change this to the z-score for 84, which is -1, and the z-score for 148, which is 3. All right. That's where we got those from. All right, here we go. Bell-shaped curve. Okay, z-score of -1 is on the left. The z-score of 3 is on the right. We want everything in between those. Our area shaded region crosses 0, so we're going to add. And the tail's not included, so 0.5 is not needed. Sorry about my bad handwriting there. So when we look up -1 in our chart, we get back 3413. That's between 0 and 1. When we look up 3 in our chart, 3.00 is 0.4987. And since we know this left and that right, we know the whole thing. We just add them together. So we're going to say 0.3413 and add 0.4987. So we get 10 add 1 is 10, add 1 is 5 is 4, and add 1 is 84. So 0.84 is the probability. 84.00% of people have an IQ between 84 and 148. Now what makes all these questions a little bit easier right now is I gave you just one example to get you warmed up, and I grabbed values that you could nicely take right off of the charts. But what if I asked you what percentage of people have an IQ more than 105? Well, 105 isn't right on the chart. I know it's between a z-score of 0 and a z-score of 1. I don't know exactly where, and I need to get precision here. Or I could ask like 130. I don't know the z-score for 130. I know that it's close to a z-score of 2, but I need to know exactly where it is. It's between 1 and 2 somewhere, and etc. So that's what we're going to do next. We're going to grab any number. So let me get this out of the way, and we'll grab another. So to answer those questions, let's ask the question, how do we find the z-score for a piece of data? Okay, well, right now, the mean is x bar, data is just x in general, and standard deviation is sigma sub n minus 1. Now don't freak out on me here. The z-score is data, which is x, minus the mean over the standard deviation. That's for those of you who love formulas. Now these formulas, see what's going to happen is after this lesson we're going to cover other lessons going forward, and these symbols change. So what I like to do is I like to keep it simple. And so I always have my students in my stats classes remember z-score is data minus mean divided by standard deviation. So if you just remember The z-score is data minus mean over standard deviation. If you say it enough times in a row, you already know what the data is, you'll know what the mean is, you'll know what the standard deviation is, and you don't have to quite rely on symbols all the time. It's kind of nice that way. Now let me show you how this works. So the manager of a hotel knows the average hotel occupancy is mean of 268 rooms per night with a standard deviation of 12 rooms. So on any given night, the average is going to be about 268 rooms are booked. The standard deviation from night to night to night is 12 rooms. Okay, find the percentage chance that on a given night the number of rooms occupied will be more than 290. Again, I can't look 290 up in my z-score chart. I have to convert to a z-score. There is no 290. I have to look up a z-score. Well, here we go. Data, which is right in the question, minus the mean. They said the mean is right here, 268. And we're going to divide it by the standard deviation, which is right there, 12. Okay, in our calculators, here we go. 290 minus 268, there we go. Enter, and we're going to divide that by 12. And we're getting back 1.833333. We're going to go to 2 decimal places. So this is 1.83. So the question now becomes, instead of more than 290, we get more than 290 is a z-score of 1.83. And now everything becomes a bell-shaped curve. So 0 is there. Positive 1.83 is to the right. We want more than that, so we draw a line. We want everything more than that, which is in the tail. Does the shaded region cross 0? No, so you're going to subtract. Is the tail involved? Yes, so 0.5 is needed. Got it? We look up 1.83. Go back over here. 1.8, 0, 1, 2, 3, 0.4664. That goes between 0 and the z-score. We know that from the mean all the way over is the right half, so this and this is half of the table. We take half, we subtract the 4664, 0, 3, 3, 6. Probability, 3.36%. Of the time, more than 290 rooms are occupied. So if you went to that manager statistically and said, what's the chance that in this hotel 290 rooms or more are going to be occupied that night? That only happens 3.36% of the time. Pretty cool. All right, so here we go. Next one. What about if it's less than 250 rooms? So let's get the z-score. So again, we have to convert to a z-score. So data, 250. The mean is still 268. And the standard deviation is still 12. So data minus mean divided by standard deviation. All right, so let me put the calculator right here. 250 minus 268 divided by 12, negative 1.5. So now we're looking at less than a z-score of negative 1.5. Bell-shaped curve. Always label the mean to be 0. Negative is on the left. We want less than. Shaded region does not cross 0, so we're going to subtract. The tail, so 0.5 is needed. Okay, we look up negative 1.5 in our chart. I'm doing it right now. We get back 0.4332. That goes between 0 and the number we just looked up. The mean all the way over to the left is half the chart. This and this is half. So if we take half right here and we take away the 4332, 0.668, 6.68% of the time, less than 250 rooms are occupied in the hotel. Okay, let's keep going. What about between 260 and 300 rooms? So now we have to do two z-score formulas. We have to do the z-score for 260. So we're going to say z-score for 260, data, which is 260, minus the mean, 268, and that's divided by the standard deviation of 12. Okay, calculator. 260 minus 268 divided by 12. Negative 0.6666, so let's say negative 0.67. And then we need the z-score for 300. Data, 300, minus the mean, 268, divided by standard deviation, 12. So here we go. 300 minus 268 divided by 12. 2.67 if we round, which we're gonna. 2 decimal places. And the third 6 rounded that second 6 up to a 7. So we want. It's about this place in the lesson that students ask me, do I have to keep on drawing these bell-shaped curves? And no. And the good thing about this online class is your tests are going to be multiple choice, so you don't have to draw the bell-shaped curves at all, and I'm sure you're probably happy about that. But they don't hurt. They, they're kind of nice in terms of visual. So we want between negative 0.67 and 2.67. So we look up negative 0.67 in our chart. Negative 0.6, go over to 7, is 2486. Let's switch colors. So this is 2486 here. And we look up 2.67, and we're looking at 4962. So this is 4962. 0.2486, add 0.4962. 8. 14 add 1 goes 14 add 1 goes 7. So it looks like 0.7448. So 74.48% of the time, the average hotel rooms occupied in this hotel are between 260 and 260 and 300. Okay, let's do another one. For you criminal justice majors out there. Okay, let me zoom out just a little. Let me get this focus back in again a little bit. There we go. Slowly, there we go. Okay. Oops, focusing for some reason a little bad there. Okay, so police response time to an emergency call is approximately normally distributed. Again, those 3 words mean bell-shaped curve. With a mean of 8.2 minutes, so that's our mean, and a standard deviation, that's a symbol for standard deviation, 1.6. Find the percentage of calls that the police arrive in less than 10 minutes. So again, we have to convert to a z-score. So z-score for 10 minutes, data, 10, minus the mean, 8.2, divided by the standard deviation, 1.6. So we got to find the z-score. All right, so I'll put the calculator over here. 10 minus 8.2 divided by 1.6. 1.125. Let's round that to 1.13. And this tells me I want less than that. So what percentage of calls are less than 10 minutes? Turns out to be less than a z-score of 1.13. We draw ourselves a bell-shaped curve. Okay. We want less than. Okay. 1.13, we're looking at 0.3708. That goes between 0 and 1.13. And the left entire half is 0.5. So if I take the 0.5 and add the 0.3708, we're getting back 0.8708, or 87.08% of emergency calls take less than 10 minutes. So there's the percentage. Cool, let's do another one. Between 5 minutes and 7 minutes. So what percentage of the time do emergency calls lie in this range? So I got to find z-scores separately for 5 and separately for 7. Data, 5, minus the mean, 8.2, divided by the standard deviation. So 5 minus 8.2 divided by 1.6. 5 minus 8.2 divided by 1.6. Negative 2 right on the nose. And then I need the z-score for 7. Data 7 minus the mean 8.2, standard deviation 1.6. 7 minus 8.2 divided by 1.6. Negative 0.75. Okay. Negative 0.75 and then negative 2. I want between these two numbers. Does the shaded region cross 0? No, so you're going to subtract. Is a tail involved? No, it's not actually. The tail's not involved, so 0.5 is not needed. So we're going to look up negative 0.75. So we look up 0.75 and we get back 0.2734 between 0 and that number. When we look up negative 2, which is really 2.00, we get back 0.4772. So this region here plus the shaded region is the 0 to negative 2, which is 4772. If I get rid of the 2734 area, that leaves me with the shaded region right there. So we're looking at point. Let's see what we got here. We got 8, we got a 3, we got a 0 and a 2. So 2038 probability. So 20.38% of emergency calls in this community take between 5 and 7 minutes. So important statistical information. I mean, that could be used at maybe a town meeting, a village meeting, where they're maybe thinking about a new contract for an ambulance service or the emergency service, or just in general, just what is the response time if somebody asked that question. You know, it'd be pretty neat to have that at hand. All right, so what if we ask the question? We're almost done. Same question we just continued on here. What if we ask the question, what is the police response time how is it more than 15 minutes? So we got to find the z-score. If you recall from the last question, the mean was 8.2 and the standard deviation abbreviated there was 1.6. So we got to find the z-score for more than 15. So data is 15 minus the mean divided by standard deviation. All right, leave that there. 15 minus 8.2 divided by 1.6, 4.25. So we're looking for more than a z-score of 4.25. More than. Okay. This is another one. We did one earlier, but it's nice to review again. If we look at our chart again, 4.25 is off the chart, so we're going to use right here, we're going to use anything bigger than 3.7, we use 4999. So we're going to go right here, we're going to say, well, that's 0.4999. And our shaded region is not crossing 0, so we subtract. The tail is involved, so 0.5 is needed, and we're going to take the right half and take away the 49.99. 0.0001, 0.01% chance. So if somebody at a town meeting or village meeting had said, what's the chance that, it could take more than 15 minutes for emergency services, you're going to say, it's possible, but it is very highly unlikely. There's very little chance, and you can say 0.01 chance that will happen. Okay. Let's try another one here. All right, last question. We're almost home free. Another one. How about the amount of money spent weekly on cleaning, repairs, and maintenance for a large restaurant? Is approximately normally distributed with a mean of $615 as the average. Standard deviation is $42. Find the percentage of time the money spent on weekly cleaning, repairs, and maintenance at this restaurant is more than 500. So the average is $615. So the mean is $615 The standard deviation is 42, because not every week it's the same. It could change from week to week depending on repairs and maintenance and what needs to be cleaned and etc. So what's the chance that it's more than 500? So we're going to convert 500 to a z-score. All right, so the data is 500. We're going to subtract the mean. It's always data minus mean. So the mean in this case is 615, and the standard deviation is 42. So there's your data minus mean over standard deviation. All right, so let's go 500 minus 615 divided by 42. We're getting back negative 2.7, let's call it 4. So we want to know what percentage is more than a z-score of negative 2.74. More than is always to the right. We cross the 0, we're going to add. In this case, the tail over here is involved, and in fact, that's everything from the mean over is half. We just have to look up the 2.74, which we notice that is going to be 49.69. So that's right there. Okay. We add the 49.69, and we're getting back 0.9969 is the probability. 99.69 is the percentage. So 99.69% of the time, the average amount of money spent on weekly cleaning, repairs, and maintenance will be more than $500 at this restaurant. So maybe the owner's selling the restaurant, and some buyers are coming in and saying, "What do you spend on, these items?" You're going to say the average is $615. So in their mind, they're thinking, well, what's the chance that I basically spend more than $500 a week? It's going to be pretty much, that's what you're going to, definitely going to be more than $500. There's a 99.69% chance you're spending more than $500, so very highly likely. And if that doesn't fit their budget, they better not buy the restaurant. All right, last one here. From the same question, what's the chance that between the spending there on those cleaning, repairs, and maintenance is between 650 and 700? So separately, the z-score for 650. Data, 650. If you recall, the mean is 615. The standard deviation was 42. So 650 minus 615 divided by 42. 0.83. And then we want to find the z-score for 700. Data 700 minus mean over standard deviation. Now, if you don't like putting it the way I put it in my calculator, you can always just simply do the subtraction if you want, like that. But I like doing it the way I do it. But if you want to put it in full, you can go 700 minus 615 divided by 42. But you have to make sure that the quantity of the subtraction, okay, because if you don't put the parentheses, you're only dividing the 615 by 42. You want to divide the subtraction by 42. 2.02. Okay. Bell-shaped curve. .83 is a positive to the right. 2.02 is a positive to the right. I went between those two. There we go. The shaded region does not cross over 0, so you subtract. The tail is not involved, so 0.5 is not going to be involved. So we look at 0.83. I haven't done this in a little while, so we'll do it again. 0.83 is right there. Okay, that's 0.2967. And that goes between 0 and that number, 2967. And then we look up 2.02. So go down 2.0, work your way over to 2, and we get back 0.4783 between 0 and 2.02. So this and the shaded is all of that between 0 and 2.02. So if we take the 0.4783 and we subtract away the 0.2967, that'll lead us with the shaded region. So we're looking at, let's see here, 6, a 1, an 8, and a 1. Okay, so we're looking at 18.16% chance that the weekly cleaning, repairs, and maintenance at this restaurant should be between $650 and $700. Okay, so we did good. We worked our way into this chart. Okay, so we're basically working on this chart. We're looking at different areas of this chart. We started with generic z-scores, and then we expanded into actually applications. And that's how you basically do normal distributions. We're going to expand on this now in our next lesson, but for now we did pretty good. So make sure that you click on the homework assignment. Any questions on the homework, please send me an email, and I'll see you on our next lesson.